Hello and welcome to part 3 of the College Algebra Exam 3 video. Let's dive right in. So question 19. A veterinarian depreciates a $10,000 x-ray machine. He estimates the resale value, V of t in dollars, after t years is 90% of its value from the previous year. Therefore, the resale value can be approximated by V of t equals 10,000 times 0.9 to the t. Find the resale value after 4 years. So, we are going to simply just put in, we know after 4 years, we're going to put that into t and find the resale value. So 10,000 times 0.9 to the 4. And when we put that into your calculator, we're going to get $6,561. If the veterinarian wants to sell his practice after 8 years after the x-ray machine was purchased, how much is the machine worth? Round to the nearest $100 should work. So we're going to do the same thing here, except for this 10,000 times 0.9 is going to be raised to the 8, because that's how many years. And so that's going to be, when we put in our calculator, $4,300. Write the logarithmic expression in exponential form. Right, so if we swap everything around, this is going to be the base, this is going to be the exponent, and that's what's going to be equal to. So that's going to be 5 to the third is equal, which is true. Right, when we have ln, this is an understood e base, so this is the base, exponent, and then what it's equal to, so e to the third. And then base, exponent, what it's equal to. Right, so go out of 21, write the exponential in log form. Right, so this is going to be the base, this is going to be equal, and then this is what's going to be equal to, and this is going to be inside the log. It's going to be log of 2 of 16 is equal to 4, because logs tell us the power. Right, base, what it's equal to, and then inside of the log. So log of 1/2 of 32 is equal to -5. Then we have the same thing, base, what it's equal to, and then the inside of the function. So log of a of b equals 9. So there's our 3 answers. Evaluate the following logarithmic expressions without a calculator. Show all work. Right, so I'm going to go here. I know that log 2, I know that 36 is equal to 2 to the 6th power. I'm just going to check that with my calculator, make sure I'm right. Yes. All right. So what we can do is we can bring this down to there. So 6 log of 2 of 2. And this log of 2 is equal to 1. So this is equal to 6. Here we know that log of 3, we know that 9 is x, is 3 squared. And since this is in the denominator, we can bring it up. So log of 3, just by changing the exponent of -2. So we're going to do the same thing, bring that down. And that's equal to 1. So this one is -2. Right, so now we have a log, which has an assumed base 10. And here we have 1, 2, 3, 4 decimal, or 4 zeros. So that means we have log of 10 to the 10th power. Move that forward. We have 4 log of 10 of 10, and that's going to go to 1. That's going to equal 4. All right. Question 23. Simplify the following expressions. So I know that 2 raised to a log, those are inverse functions of each other. So I know that they're going to reduce each other out, and that's just going to be equal to x minus y. For this one, we can use what we've been doing in the last problem. We can drop that forward. So 13 log of 7, and that's just going to go to 1, so that's going to be equal to 13. This one, we have log of e, or the natural log of e, which these are inverse functions of each other, so they're going to reduce each other, and we're just going to be left with the inside function, so this should be equal to x squared plus 2. Right, so we have base p of p, we know that's just going to equal 1, and then ln of 1, we know that anything raised to the 0th power is equal to 1, so we know that this is equal to 0. All right. Identify the shifts from the graph from the parent function log of 2 of x to the graph related to the function g of x, log of 2 of x plus 5 minus 2. So I'm going to identify the shifts. We don't have any stretching or compression here, so we don't have this a or c term, so we can ignore those. We do, however, have or this is a b term. We do have this c term, and we do have this d term. So we know that since this is plus 5, we're going to move to the left. Oops. Moving to the left 5, and we're minus 2. That means we're moving down 2 units. So those are the 2 shifts that are happening to this function since there's no compression or stretching happening. All right, page 2 of part 3, question 25. Apply the product, quotient, and power rule properties of logarithms. Simplify if possible. So the first thing we're going to do is simplify this inside a bit. Since we have the 7th root, we can just put that in the divisor of the power. So that's going to be x to the 5th divided by 7. And then we're going to move that to the front. So that's going to be 5/7 log of 4 to the x. And that is all we can do to simplify it further. This one, we're going to take it apart since we are dividing here by 100 and m squared plus n, we're going to separate those out. It's going to be equal to m log of m squared plus n. And then since we're dividing, that's going to be subtraction. So minus log of 100. Right, and what we know is log has an understood base 10. There's 1, 2 zeros, so this is going to be equal to log of plus n. Right, and that's going to go to the front. This is going to go to 1, and that's going to give us log of m squared plus n minus 2. And that's the furthest we can simplify that. This one too. Part C. So here we have multiplication, so we can split that. So log of 749, and since we're multiplying, that's going to be a plus. Log of 7 to the k. And then we know that this is 7 squared here, so that's going to be equal to log of 7 squared plus log of 7k. And then we're going to move it, and this is going to go to 1, so that's going to be equal to 2 plus log of 7k. And we can't simplify that any further. Right, so part or number 26, write the logarithm ln of that as a sum or difference of logarithms, simplify each term. So the first thing we do is we have this fourth root here. So that's going to have everything to the fourth. So we're going to drop that in front. So this is going to be 1/4 ln of x plus 4e to the 3. And now we have this division here. So we are going to expand that. So we have 1/4 ln of x squared plus y on top. And then we have the e to the 3 on bottom. Since we're dividing, it's subtraction. 1/4 ln of e to the 3rd. All right, and ln has this understood base e, so these are going to cancel. This is going to drop, and that's going to be, we're going to be left with 1/4 ln of x squared plus y minus 3/4. And we can't simplify this any further because we're adding. There's no rules with that. That's when we're multiplying. We can't move this exponent right here because of the y. And so this is the simplest form we can be in. Oh, hold on. This is a 4. Sorry, my handwriting kind of got to me. This is a 4 and a 4. Okay. All right. Number 27, write the logarithm expression as a single logarithm with a coefficient of 1. All right, so the first thing we're going to do is we're going to put all of our coefficients back on top. So this is now going to be log 6th of r to the 4th minus log 6th, log 6 of s to the 3rd minus log of 6t squared. And now we're going to do our combination because we have these minus signs, so that means we're going to divide both of them. So that's going to be equal to log of 6 times r of the 4th to s to the 3rd to t squared. And that's the furthest we can simplify that. Number 28, the variable pH in the formula pH is equal to the negative log of the hydrogen atom represents little acidity or alkalinity of a liquid, and H plus is in moles, is the concentration of hydronium ions in the solution. Determine the pH of the following: a tomato with a concentration of 6.3 times 10 to the negative 5, and milk of magnesia with that. So what we can do is we're determining the pH, so that means we can just plug this into our log, and so we'll have the, for A, our part 1, I should say, 1, we'll just have the negative log of 26 times 10 to the negative 5. Okay, so I'm going to plug that into my calculator. So negative log of 6.31 times 10 to the negative 5th. And that's going to give me a pH of 4.2. For part 2, I will do the same thing. Negative log of 3.16 times 10 to the negative 11. 11. I'll put that in my calculator. Negative log 6 times 10 to the negative 11. And that's going to give me a pH of 10.5. So those are my two pHs. And this is determine the H plus of the following. So now we need to put this in terms of of the concentration, or in terms of the pH, so we can get the concentration. So we have pH negative log of H plus. So first we got to multiply this over. Negative pH is equal to log plus. So now we have to do the inverse function. The inverse logarithm is 10, base 10 of to the negative pH, and that will be equal to our H plus concentration. Right, so I'm just simply going to put 10 to the negative 2.6. Make sure I put my parentheses around the negative sign. And that's going to be a concentration of 2.5 times 10 to the negative 6 moles per liter for the onion. And then for baking soda, same thing, 10 to the negative 8.4. That's going to be equal to 10 to the parentheses, negative 8.4, close parentheses, 3.98 times 10 to the negative 9 moles per liter. All right. So 29. Given that log B of 2 is around 3.56 and log of B of 3 is around 0.565, approximate log of 24 show all work. So what we know is that log of B, we know this, and so what we can do is we can rearrange that equation. So if we take this all to the B power, right, these are inverse functions of each other, and that will just leave us 2. So that means that 2 is about equal to B to the 0.36. And then what we can do is that we can raise this whole equation to 1 over. So I'm going to have B is about equal to 2 to the 1 over. And then I'm going to put that in my calculator. 2 raised to the parentheses 1 divided by 0.356, close parentheses, and I'll get B is about 7. So now I will put in my calculator log of 24 divided by log of 7, and I'll get about log of 24 divided by log of 7, and I get about 1.633. Use the change of base formula to evaluate log of 23 or log of 6 using base 10 or base E. Show all work. So I know that log of 23 over 6 is equivalent to log 10 of 23 divided by log 10 over 6. So I can just put log of 23 in my calculator divided by log of 6, and I will get about 1.75. All right, question 31. Solve the following exponential equations. Give an exact solution and an approximation to 4 decimal places as needed. Show all work. All right, so what we can do is, for this one, we know that 625 is equal to 5 to the 4th. And once we know that, we can set each plate equal to log of 5 of 5. Log of 5 of 4. Right, and we know that these are inverses of each other, so they cancel each other out, and that will just leave us with 3x minus 2 is equal to 4. And then move that over, we have 3x is equal to 6, and so x is equal to 2. Next question, we're going to start by moving this 8 over. So we have 6 to the 2x minus 5 is equal to 20. And then we're going to do the log of each side. So log of 6 to the 5. So 20. And these are inverse functions. So that's going to leave us with 2x minus 5 is equal to log of 20 divided by log of 6. And then we're going to add 5. It's going to be 2x equal to log of 20 over log of 6 plus 5. And then divide by 2 of x is equal to log of 20 divided by 2 log of 6 plus 5 over 2. And this is going to be our exact answer. And then x is going to be equal to log of 20 divided by 2 divided by the log of 6 plus 5 divided by 2. It's going to be equal to about 3.34. Oh, hold on. It says round to 4 decimal places, so that's going to be equal to x is equal to 3, and then 6, 0. Question C. We have that. So for part C, we are just going to set each side equal to the natural log. So we'll have the natural log of 4, x plus is equal to the natural log of 6 minus 4. So we can move these forward. Equal to x plus 2 times the ln of 4, which is equal to, natural log of 6. And now we are going to multiply each side. So that's going to be ln of 4x to the ln of 4. X and then we're going to get our x's on the same side. So we're going to have 3x ln, move this over, and then move that over. So 3 ln of 6 minus x ln of 4. Is equal to 2 ln of 4 plus 4 ln of 6. Take the x out, 3 ln of 6 minus ln of 4 is equal to 2 minus 4 minus 6. And then divide, so x is going to be equal to 2 ln of 4 plus 4 ln of 6 over 3 ln of 6 minus ln of 4. And so this is going to be our exact answer, and that's going to be equal to, make sure you are doing the correct parentheses in your calculator. It is very important. So, parenthesis of 2 times ln of 4, close parentheses, plus 4 ln of 6, close parentheses, divided by open parentheses, 3 ln of 6 close parentheses minus ln of 4 close parentheses, and that's going to give us a value of 3.4918. Okay, so part D, we have this. This is going to be equal to e to the x squared plus 2e to the x minus 4 equals 0. So what we have here is a quadratic. Basically, we can separate this into 6 and minus 4, and that's going to be 6 times 4. So we have e to the x minus 6, or plus 6, times e to the x minus 4 equals 0. So we have e to the x plus 6 equals 0. Move that over, e to the x equals negative 6. This will never happen. So there's no solution for that one. No solution. Let me check this one. E to the x minus 4 equals 0. E to the x equals 4. Then we do ln of e to the x equals ln of 4. Those are inverse functions, so x is equal to ln of 4. And that will be your answer. And that is also equal to 1.3863. So that is part 3 of your college exam review video. There's going to be a part 4 finishing it, and I hope to see you there.